Hi, ladies. We've only a couple days left, and we're going to be wrapping up. So today we're going to go back to Chapter 6 and work on balancing equations. We'll do a little bit more with these next week, but this is the last topic to talk about and learn in Chapter 6. So let's go ahead and get started with a prayer. I'm reverting back to a prayer that we did once before, and I noticed that there were a few other people who are, there's been some more prayer requests and special intentions up, so just kind of noting these. There's a lot of family and a lot of people that we're praying for. So let's start with the morning prayer. In the name of the Father, the Son, and the Holy Spirit, amen. Thank you for loving me, for walking with me, and for caring about the smallest details in my life. Fill me with grace, Lord, that I may have the strength to face what is before me today. I know not what today will bring forth, but make me ready, Lord, for whatever it may be. In the name of the Father, the Son, and the Holy Spirit, amen. So there is not a whole lot of class update today, no prime time. We're going to review a lot of answers. I'm going to be pausing a lot for you to go over and take a look and have you make notes on any ones that you have questions on. We're going to talk about 6.3. I'm going to spend the majority of the time practicing this with you and then having you do some practice on it on your own over the weekend. So 3 classes left. Today we're doing balancing of equations. Tuesday I'll introduce naming of acids. Not a big topic, a pretty small topic, and then we're going to spend the rest of the time on Tuesday practicing naming of everything, and Thursday practicing naming and doing some balancing of chemical equations and maybe some recommendations for the summer. So personal update. Everybody's kind of said how much they like seeing my dogs, and so I decided to pull out some pictures of my former 2 dogs who we had. The top 2 here, we have Cookie and Cream, and they were sisters. They were from the same litter. We got them in Texas. They moved with us to Singapore. They moved back to the United States to mentor and then returned to Texas with us, where they died of a very old age, but they were great dogs. And then you've heard about Coco and Carmel, who are the 2 current dogs who are also sister from the same litter. And you notice we've got this common theme with the C's going on, and Coco looks a little bit like Cookie. And while Carmel doesn't look like Cream, every once in a while we'll call the dog by the previous dog who was similar to them's names, because we've got all these C's going on. But those were our 4 dogs. And the 2 current dogs, they're still in training. We've got a number of weeks left because quarantine kind of shut us down. They're not liking it one bit, but they're learning. And things are getting better here at the house. Hopefully in another few more weeks, we'll be able to trust the 2 of them to not snarl and growl at each other at all. And they've been doing okay. So good news on that front. So chapter 6 topics, as I mentioned, we've got acids left and balancing chemical equations. All right, so something that kind of came up during the test, some people's periodic table of the elements, the key that you have is different than the key that I have. So some people have their nonmetals and metalloids colors reversed, and they have them labeled incorrectly. So I've said many, many times that the metalloids are the stair step, and the nonmetals are these ones on the the right-hand side of your page. So ladies, double check, and if yours is wrong, which probably everybody's is, fix it. A lot of you got these right on the test anyway, so I think many of you had already noted that and fixed that. I've had a few people who've notified me of that. I've done a little bit of adjustment to grades on the online quiz. So if you are one of those people and maybe I didn't catch yours, let me know. Send me an email or put it in the comments in the survey. So answers to pages 19 and 20. I've handwritten in a few things here where we had a lot of Roman numerals that weren't originally included on these solutions. So I am not going to go through all of these because I told you guys you should do what you feel you need to do. So pause it, take a look at them, make notes of the ones that you didn't do correctly, and you can ask me questions. 21, similarly, we did a number of these in the last class. I'm hoping that most of you were getting pretty good at that and doing okay with identifying which ones are covalent, which ones are ionic. And you guys all should be very good at counting the number of atoms in the compound at this stage. So pause the video and take a look at your answers. Again, pages 25 and 26, we've got a number of things here, and I know it says ionic or molecular. You're welcome to call them covalent. Your book calls them covalent. I still call them covalent. Either word is fine. But here are the ones that you should have answered, and I know that in this portion, I had you just write a table of prefixes here, which you'd already copied down in the notes, and you should have already done up through 1 through 10. So pause the video, make certain you guys are good here, and if you have any questions, put them in your survey or send me an email, and I'm happy to get back with you. So practice naming. I think you still need some practice. So right now it's your choice. What do you need to practice the most? So options, you can practice ionic naming, which is on page 18. You can practice covalent, which is on page 28. Or you can mix them up, which is on pages 37 and 38. And one of those has the formula and the other one has the name. So practice what you think is best for you at this stage. Now, you don't need to do all of the problems on any of these pages. Practice some of them for a reasonable amount of time. It's fine. And on whatever you select, right at the top, I selected this page because blank. Just let me know kind of what you're thinking at this point. I totally understand that you guys are not 100% comfortable with these. I know that. I knew that when I decided I was going to go ahead and cover this material anyway. Legitimately, I probably shouldn't have started it, but I know that this is one thing that if I cover with you guys and then you see it again next year with either Mrs. Iskander or Mrs. Hamrick, it'll be easier next year. Okay, the time that you've invested now will make it easier next year. And I have no idea what the fall is going to bring. I'm guessing it might not be as ideal as we would like it to be. And if that's the case, anything that we can do to make your life easier in the fall, I think is a good thing. And also, like I told you previously on one of the videos, that I felt very strongly that just because this COVID thing happened and we're doing stay at home doesn't mean that I should not try to prepare you and set you up in the best way possible for next year. Okay, so that's what this naming is about. Practicing, trying to get you a little bit more comfortable. I know you're not going to be perfect at it. You're not going to be as good as if we had spent a lot of time in class together. You're not going to be as good if we'd had as many days in class to do this. I get that. I understand. Just try, okay? So that's what's important because I'm really trying to make this easier for you next year. So again, the naming, I don't expect you to do all these pages. I don't expect you to do all the problems on any of the pages. I do expect that you're going to try something and use a little bit of thinking in which one you are actually choosing. So I'm going to show you a couple of short chemistry videos on 2 different reactions. So here's the first one. You've probably seen this before. Here we go. So then I do the same thing with red. So that's elephant toothpaste, which you may have seen before. And here's another one that's similar, but yet just a little bit different. So decomposition of sugar using sulfuric acid. So he's got to mix it up and kind of get it all well mixed, and he's obviously speeding this all up. And he's working in a fume hood, so he's turned the fume hood on so you can see it. You can see all the smoke giving off. So he's going to show what the reaction is that's going to happen. So he's got the guest starring the reactants, which is sugar and sulfuric acid, and the products are solid carbon and steam. So two chemical reactions that are pretty commonly done in demos for you to see, and I'm betting you probably have seen some of those in the past. So I want to move on today in your magenta packet, pages 9 and 10, and start taking notes on balancing chemical equations. So starting on page 9, we've got chemical equations represent a chemical reaction. Sometimes they are not balanced, but this must be done before the equation can be used in any meaningful way. If you do some calculations with a chemical equation that's not balanced, it will have meaningless results. So all chemical calculations must be done with a balanced equation. And a balanced equation is one that has equal numbers of each type of atom on each side of the equation. The law of conservation of mass says in a chemical reaction, the total mass of the reactants equals the total mass of the products. Another way of saying it is matter can be neither created nor destroyed. Therefore, we must finish our chemical reaction with the same number of atoms of each element as when we started. So for example, we have a chemical reaction, H2 plus O2 yields H2O. 2 atoms plus of hydrogen plus 2 atoms of oxygen yields 2 atoms of hydrogen plus 1 atom of oxygen. But where did that extra oxygen go? So this equation is not balanced, which means that we have to balance it so that there are equal numbers of atoms on both sides. So remember this, a balanced equation must have equal numbers of each type of atom on both sides of the equation. So this statement should be copied down in the gray box on that page. An equation is balanced by changing coefficients in a somewhat trial and error fashion. Please note that the coefficients can be changed, but the subscripts can never be changed, because when you change a subscript, you're changing what the chemical is. So some hints, balance elements that exist in compounds with odd number of atoms, balance elements that occur only once on each side, and if an element exists as a free element on one side, balance that element last. So these hints will make more sense as we do some examples. So the first example is H2 plus O2 yields water. So the best way to do this is to start out with a table where you write down all of the elements in this first column, and you leave yourself a space in the table for the reactants and the products. So we're going to go through and we're going to count our atoms, which is why we started doing this back in chapter 4. So determine how many of each element there are initially on the reactant side. So there are 2 hydrogens and there are 2 oxygens. And then we're going to look at the product side. So there are 2 hydrogens and there's 1 oxygen. So we know that this is not balanced. So if the numbers don't match on the reactant and product side, we're going to have to use coefficients to balance the equation. So first, we're going to try to add some oxygen to the product side. And when we put a 2 in front of the H2O, we now have 4 hydrogens and 2 oxygens. And now we go back and we look here, and are we balanced? Well, no, our hydrogens aren't, but our oxygens are. So we still have to do something. So the next thing we're going to want to do is see if we can get more hydrogens on the reactant side. So if we put a 2 in front of the H2, we now have 4 hydrogens. So now we have 4 hydrogens in the reactants and the products and 2 oxygens in the reactants and the products. So we are balanced. So now we have a balanced equation. So remember things that the coefficient times the subscript gives the total number of atoms. Some 3 quick examples to try, so let's take a look at these. 2H2, how many hydrogen atoms are there? There's 2 times 2, which is 4. How about with 2 in front of the H2O? We now have 2 times 2, which is 4 hydrogen atoms, but 2 times 1 for the oxygen atoms. So we have 4 and then 2. Now here's one that's a little bit harder. So nitrogen atoms, there's 1 inside the parentheses. Outside the parentheses, you get 2, and then you multiply that by 2 to get the total number of nitrogen, and that would be 4. Hydrogen, we've got 4 inside, 2 outside, 2 of those, so that's 4 times 2, which is 8, times another 2, which is 16. And sulfur, there are no subscripts, so it's only the 2 times the 1 sulfur, so you end up with 2. So 2 things you cannot do when balancing an equation. 1, you cannot change a subscript. For example, you cannot change the oxygen subscript in water from 1 to 2 as in doing this. If you do this, you've changed the compound. H2O becomes now a completely different substance. H2O2 is very different. So you wash your hair with water, but you actually bleach your hair with peroxide. So you can't do that. The second thing, little cute saying here. 2 men walk into a bar, one orders H2O, the second says, I'll have some H2O too, and the second man died. So number 2, you cannot place a coefficient in the middle of a chemical formula. So the coefficient must go at the beginning of a formula, not in the middle, as in this. You cannot just write a random coefficient in the middle of H2O. Also, you must be sure your final coefficients are all whole numbers with no common factors other than 1. You can't have half of an H2O molecule. There's no way to do that. So for example, if you had an equation like this, all of these numbers are divisible by 2. You could simplify this. So this equation is balanced, having the same number of atoms of each element on both sides. However, all the coefficients have a common factor of 2. So you can divide them all by 2 and end up with this equation. It means the same thing, but this is a correctly balanced equation, and it is in its simplest form. So let's try these ones that are on the bottom of the page. So we've got H2 and Cl2 yields HCl. So make your table, reactants and products. determine how many of each element there are initially on the reactant side. So when we count hydrogens, I get 2. When we count chlorines, I get 2. And then on the product side, we're going to do the same thing. I see 1 hydrogen and 1 chlorine. So we know we're not balanced. So in order to balance them, we have to get more hydrogen and chlorine on the product side. So let's try changing that coefficient. When we do that and change the coefficient in front of HCl to 2, we end up with 2 hydrogens and 2 chlorines. And now it looks like we're balanced. So that is our balanced equation. So then we have FeO2 goes to Fe2O3. So doing the same thing, list your elements, FeO, count them on each side. So I see 1 iron and 2 oxygens. And then on the product side, I see 2 irons and 3 oxygens. And we're obviously not balanced. So we're going to use some coefficients. And in this case, because we had a 2 and a 3, we are going to try to make both of those to be 6. So we have, if we put a 3 in front of the oxygen, we get 6 on the reactant side. We put a 2 in front of the Fe2O3, we now have 4 irons, and then 2 times 3, which is 6 oxygens. So now our oxygens are balanced, but our iron is not. So now we're going to need to change the number here in front of Fe to allow us to have 4 irons here. So what are we going to put in front of the Fe symbol? Yeah, you guessed it, it was 4. So now we're balanced. All right, so let's go to page 11. We're going to do these one at a time. So this is what page 11 looks like, and it asks you to identify if it's balanced, and then if it is not balanced, determine what the balanced equation would be and write it below. So we've got CaO plus H2O yields CaOH2. So here when I'm counting, I see that there's 1 calcium. And for oxygen, we have 1 here and 1 here. So that means that there's a total of 2. Hydrogens, there are a total of 2. Now we can go to the product side. We've got calcium, there's 1. Oxygen, there are 2 because the parentheses and the subscript here tell us that there's going to be 2. Hydrogen, there's the parentheses with the subscript, so there's going to be 2. So here, wow, we're actually balanced, right? We've got all of the numbers here are the same on both sides of the equation. So this one is balanced and there's nothing more you have to do. Let's go on to number 2. PCl5 plus H2O. So we're going to start the same way. Have our table and figure out the number of atoms. So phosphorus, there's 1. Chlorine, I see 5. Oxygen, I see 1. And hydrogen, I see 2. Then on the other side, phosphorus, I see 1. Chlorine, I see 4. Sorry, there's 3 here with the POCl3, and then there's 1 more in the hydrochloric acid, so there's 3 plus 1, which is 4. Then oxygen, the only one is here, so there's 1. And then hydrogen, there's only 1 in the 1 compound, so that's what we've got. So obviously we're unbalanced, so we're going to have to try to figure it out. So when we start with this, notice that we're unbalanced in the chlorine and the hydrogen. So let's try to see, because we need a few more over here in the product side. What if we change the coefficient for HCl? Let's see what that would do for us. So if we change the coefficient for the HCl to 2, we now will have chlorine. We have 3 here and 2 more, which makes 5. And when we change that to 2, we've now got 2 hydrogens. So, but just by changing the one coefficient, we now look like we're balanced. Number 3. 3 looks very similar. Okay, so we've got similar similar atoms. So phosphorus, we have 1. Chlorine, we have 3. Oxygen, we have 2. Hydrogen, we have 2. Then on the other side, I see there's 1 phosphorus. Chlorine, there's 1. Oxygen, there's 4. And hydrogen, there's 3 in the one compound and 1 in the other, so that gives us 4. So this one is unbalanced. So it's really kind of helpful to start with any odd numbers because those seem to be the more challenging typically to balance if we can, especially if they're only appearing in one compound on each side. So with the chlorine here, let's start trying to get the right number of chlorine on the product side. So if we bump that to 3, we now have hydrogens. We have 3 plus 3, which is 6. And chlorines, we have 3 chlorines here. So now we're balanced with phosphorus and chlorine, but not oxygen and hydrogen. However, it looks like we might be able to get this to work by doing something with H2O. So let's see if we change that. We change that to a 3, so we can end up with 6 hydrogens. What do we have as far as oxygens then? We have 3 oxygens here and 1 here, which makes 4. So now it's balanced. All right, so number 4. Which law of nature is the reason why reactants and products in a chemical reaction in a closed system must have the same number of each type of atom? This is conservation of mass. So, some tips to doing this on your own. Remember, it's trial and error, and there are some that are easier than others, and it takes, yeah, you guessed it, practice. So always make a table because it really helps. Even people who've been doing these for years and years still make a table. It is way too hard to do this without a table because you make mistakes. So always adjust coefficients and never subscripts. Look at your most complicated compounds first. Even and odd, so sometimes you have to multiply by 2 to make those odd numbers even. You've got to try to balance those things that are even and odd. Remember to balance your polyatomic ions as a whole. Leave any individual elements until last, and those could be something like a diatomic molecule of oxygen or a metal like nickel and copper. Those are way easier to do all the way at the end. So do everything else and leave those. And then don't worry about how large the coefficients get or the number of atoms because it's always possible to reduce them and simplify them at the end. And you're going to check your work and then reduce if possible. So if you've gone through and done a whole bunch of manipulations, you might end up having the wrong numbers of atoms. Go back and check your work before you say that the equation is balanced. So I'm going to say you want to do page 12 for homework. So on this, it's got balancing equations, and all you're doing is checking to see if the equation is balanced or not. You don't have to balance it here, okay? So this is supposed to be a self-checking type of page because on page 13, there's a coloring sheet of a peacock for you to color. Now, you don't have to color in page 13. I'm leaving that as optional. A lot of you like coloring. A lot of you find it relaxing. You are welcome to do this. I will give you credit if you do page 13, but you don't have to do it, okay? I'm going to assign you some other ones for you to actually do the balancing, but I really want to practice some more with you before I assign those. So this page is going to be one where you're going to be looking and just counting atoms and seeing if you have enough and if it's balanced. So I am going to be working on page 15, these have some more challenging ones. I don't know that I'm going to do all of them on here, but I'm going to do quite a few. So page 15, we start out with number 1. And here I see there's 1 iron, there's 2 hydrogens, 1 sulfur, 4 oxygens. And then on the product side, we've got 2 irons, 3 sulfurs, 12 oxygens, and 2 hydrogens. So looking at what we've got, we can try are things like iron. It's by itself, so that's actually kind of a good thing to leave to the end. In the product side, hydrogen is by itself, so let's leave that to the end. But I noticed that sulfur has an odd number, and oxygen is way off. So let's start with those. Let's see what we can do. So by looking at this, I can tell that I need to get some more oxygens on the reactant side. So I am going to try to get 12 over there. So when I do that, I can put a 3 in front of that. So now that's going to change my number of a lot of these atoms. So this is where I'm finding that colored pens and markers will help you guys in deciding what to do. And when you go back and look at it, it'll make more sense. So 3 times 2 is 6. And sulfurs, there are 3. And oxygens, there are 12. So now we're balanced in a little bit more. And now the only thing we're left not balanced in is in our hydrogens. So we have 6 on the reactants and 2 on the product. So if we put 3 in front of hydrogen over here, we get 6. So now our coefficients are going to be 1, 3, 1, and 3. And we are balanced. I'm going to write number 2. Okay, I lied. I'm going to do number 3. Number 2 is kind of hard, so I'm going to wait and do that later. So number 3, I've written my formula, I've drawn my table, and I recommend using another sheet of paper to try to do this because it's really hard to cram all that in these spaces on here. And if you do that, that's where we tend to make mistakes when we're trying to cram all these little numbers in here. So looking at what we've got, I see there's 1 potassium, there's 1 plus 4 oxygen, so that's 5. There's 1 plus 3 hydrogens, which is 4. And then there's 1 phosphorus. And then on the product side, I see there are 3 potassiums. Phosphorus, there's 1. Oxygen, there's 4 plus 1, which is 5. And hydrogen, there are 2. So the things that we are not balanced in are going to be potassium and hydrogen. So I think we should start with potassium because it's got 3 of them. So let's see what we can do here. So if we start with potassium and we want to get 3 on the reactants because we have 3 on the products, we're going to have to put a 3 in front of here. So when we do that, we now have 3 potassium. Oxygen, we have 3 plus 4, which is 7. And hydrogen, we have 3 plus 3, which is 6. So now we've got a couple more things that are not balanced, but let's take a look. We've got oxygen and hydrogen that's not balanced, and we need more of them on the product side. So I'm thinking we can change the amount of water. So we have 6 on the reactants. We will only have 2 on the product. So if we multiply this guy by 3, we'll end up with 6. So now over on the product side for hydrogen, we've got 6. For oxygen, we have 4 plus 3, which is 7. And now we're balanced. So that's another one. So I'm going to pause my video and write the next one. Okay, so here's number 4. So we've got 10, and let's figure out how many we've got. So we've got 1 on the reactant. On the reactant, we have 2 oxygen and we have 2 hydrogen. That looks good. And then on the product side, we have 1 tin. We have 2 hydrogen and 1 oxygen. Oh, so it looks like we don't have the right number of oxygens. So let's try to fix that. So to get 2 on our product side, we're going to have to put a 2 here in the front. When we do that, we now have 2 oxygens and we have 4 hydrogens. Okay, so that messed up our hydrogens, but I think this is easily fixed. We have 4 on the products. We only have 2 on the reactants, but it's in the form of H2. So if we put a 2 in front of that, that's going to make that 4. So now we are balanced. And that's another one. So I'm going to pause my video and write the next one. Okay, so let's take a look at what we've got here. So I've skipped number 5 because it was kind of hard also. I'm doing number 6. So I've got 1 potassium, I've got 1 nitrogen, oxygen, I see there's 3 and 3, which makes 6. Hydrogen, there are 2, and carbon, there is 1. And then on the product side, there are 2 potassiums, there's 1 nitrogen, oxygen, there's 3 in the first compound, 3 in the second, which makes 6. Hydrogen, there's 1, and then carbon, there is 1. Okay, so we're not balanced in a couple of things. We're not balanced in potassium, we're not balanced in hydrogen. So let's fix one of those first. Let's go ahead and just pick one. We'll pick potassium. So let's go with potassium. We have 2 on the product side. We want 2 on the reactant side. The only way to do that is to put a 2 in front of that. So when we do that, we now have 2 potassiums, 2 nitrogen. Oxygen becomes 6 plus 3. Right? 6 plus 3, which equals 9. Okay, so that's a little bit better. Now we've got to try to fix H, N, and O, right? So we've got to fix NOH. Oh, that's nice because we've got one compound here that has HNO3. So let's try to fix the hydrogens now. So to do that, we've got 2 on the reactant, only 1 on the product. We want to have 2 there. So when we do that, we now have 2 hydrogens and we have 2 nitrogens. And our oxygen ends up being 6 plus 3, which equals 9. Nice. All right. So it looks like when I check all of these are now, it's all balanced. So that's another example. There were a couple more steps here, but it's not too bad. Okay, so let's do these. So boron, I see there's 2 in that first compound. Bromine, there are 6. Hydrogen, there's 1. Nitrogen, there's 1. Oxygen, there's 3. And then on the other side, I see 1 boron. Nitrogen, there's 1 times 3, which is 3. Oxygen, there's 3 times 3, which is 9. Hydrogen, there's 1. Bromine, there's 1. Okay, so looking at what's not balanced, there's actually quite a bit. I'm thinking we should try to fix our bromines first. So let's fix those first. So to do that, we've got 6 on the reactant. We have this hydrogen bromide on the product. So let's put a 6 in front of here and let's fix that. So that'll be 6 of those. And now there's 6 hydrogens. Okay, now our hydrogens are messed up. So let's see if we can fix that. So we've got 6 hydrogens on the one side. We've got to get 6 on the other. Let's see what that did to us. So now we have 6 hydrogens here. Nitrogens, we have 6. And oxygens, we have 6 times 3, which is 18. All right. So let's fix our borons. So we've got 2 on the one side, 1 on the other. It's only in the one compound, so we've got 2 there. So now we've got 2 nitrogens. We have 3 times 2, which is 6. Oxygen, we've got 3 times 3, which is 9, times 2, right? 3 times 3 times 2. 9 times 2 is 18. And I think now we're good, right? These are all equal. So this guy is balanced. All right, let's try number 8. Okay, here's number 8. So we've got to start counting atoms. So boron, we've got 1. Fluorine, I see 3. Lithium, I see 2. Sulfur, there's 1. And oxygen, there are 3. And then on the product side, there's 2 borons. There's 3 sulfurs. There's 9 oxygen. There's 1 lithium. And there's 1 fluorine. All right. So if I look at this one, if I look at lithium and fluorine, we've got 2. We won't need 2 here and 3 here. But in order to do that, we're not going to be able to do that easily unless we take everything, all of these, to 6. Okay? So we are going to take all of these to try to get 6 of each of these molecules, and then we're just going to recount everything. So 6 in front of the lithium fluoride is going to give us 6 of these and 6 of those. And then if I want to get to 6 lithium here, I'm going to put a 3 here. So that's going to be 6 of those, 3 sulfurs, and 9 oxygens. And if I want to get to 6 fluorines, I have to put a 2 in front of here. So now I've got 2 and I've got 6. So let's see what we've got. These are good, these are good, these are good, these are good, and these are good. Wow. Okay, so you could have done that in multiple steps, but I stopped and realized that I had this 2 and 3 going on with my lithium and fluorine, and because they're both in the same compound, I can't have 2 of one and 3 of the other. That just was not going to work. So sometimes with some practice, you'll see some of these things. Now, you may not see it right off the get-go, and it's okay if you adjusted one. As long as you keep the numbers in your table correct, you will eventually get there. It might take you a few more steps, but a few more steps is okay. All right. So let's take a look at this one. This one's got a lot of stuff in it. All right, nitrogen on the reactant side. I see there's 3 here, and there are 4 there, so that makes 7. Hydrogen, there are 4 times 3, which is 12. Phosphorus, there's 1. Oxygen, there's 4, and then there's 3 times 4, which is 12. So 4 plus 12 equals 16. And then lead, there's 1. Then on the product side, we've got, I'm going to just go through from right or from left to right. So lead, there's 1. Phosphorus, there's 1. Oxygen, there's 16 there, plus 3, which is 19. Nitrogen, there are 2. Hydrogen, there's 4. Okay, this is kind of ugly. So taking a look at this, oh, and I left off a 3 here. So that makes this lead 3. Okay, so taking a look at this, I would say that we've got this factor, oh, I wrote it in the wrong place, 3, 1. Sorry about that, ladies. Okay, so we've got 2, 4, 4, 19, and 3. Okay, I did that way wrong. I'm going to just do that all again. Okay, I want to start that over. So I've got lead, I have 1. Phosphorus, I have 1 times 4, which is 4. Oxygen, 16 plus 3 is 19. Nitrogen's 1, 2. Hydrogen's 4. Now, that's right. 2, 4, 4, 19. And I did it again. That's 3. Okay. So, looking at this, there is nothing really obvious. However, I'm going to start with this odd number with the lead because there's a 3 and a 1. So let's just see if we can fix that and see what that does for us. So when I do that and I put a 3 in front of here, I've now got a 3. Nitrogen is 4 times 3, which is 12. Oxygen is 3 times 4, which is 12, times 3, which makes it 36, plus these 4, which makes it 40. Oh, that's a lot. All right. So now I think we're good there, unless I mess something else up. Oh, we did. Nitrogen. So there's 4 times 3, which is 12. Plus 3, which is 15. So this is 15. All right. Now I think we're good. 15, 12, 1, 40, and 3. Okay. So the next one, we have to try to fix, let's look at our phosphorus. Let's go ahead and try to fix that because we have 4 and 1, and there's only 1 compound over here. So that would be 4 of those. So we're fixing phosphorus. So 3 nitrogens times 4 is 12, plus the 12 times 3, which is or 4 times 3, which is 12. So now we've got 24. Then we've got, so we just did nitrogen. Hydrogen is 4 times 3, which is 12, times 4 is 48. Phosphorus is 4. Oxygen, 4 times 4 is 16. And then we've got 12 times 3 is 36. So that equals 52. So I've got 24, 48, 4, 52, and 3, and we're actually looking pretty good here. So in order to finish this up, we need to get this these numbers just a little bit different. So in order to do that, we've got, looking at our nitrogen, we've got 24 here and 2 there, and the only compound that has nitrogen on the reactant side is this one. So this is, we've got 2 there. We need to make it 24, so we need 12 in front of here. So now we've got 12 times 2, which is 24. And hydrogens, we've got 4 times 12, which is 48. Oxygens, we've got 3 times 12, which is 36, and we also have 4 times 4, which is 16, which is 52. And now, lo and behold, we are actually balanced. Thank goodness. That was kind of a messy one. Sorry that was so messy, ladies. Okay, so this is number 10, the last one on this page, and I promise this one's easier. So here we've got selenium, there's 1, chlorine, there's 6, oxygen, there's 2. On the other side, we've got 1 selenium, 2 oxygens, and 2 chlorines. So in this one, the only thing that has an issue is our chlorines. So as soon as we fix our chlorines, we're going to be fine. So we have 6 on the one side, and we need to make 6 on this side. So we put a 3 there, and now we've got 6, and it's actually balanced. So ladies, there are ugly ones in here. There are challenging ones in here. I skipped 2 of them. I might show them to you later on, but not today, especially since I had so many stops and starts in problem number 9. So I want to go back to the PowerPoint to kind of wrap up. So for practice, I want you to look at pages 17 and 18 and do at least 10 successfully. These do not have ones that are nasty like number 9. I showed you some more challenging ones. I showed you some harder ones that had more steps. A lot of these do not have more than 1 step. There's actually some of them in here that are already balanced. So if some are hard and you're not having any luck, skip them and try another one. It's okay. And sometimes, just like what I did in number 9, I kind of had to erase what I did and kind of restart because it was getting too confusing. So try to do at least 10. That does not mean 1 through 10. If you start with 1 and you keep on going and some number is hard for you, stop, try, go on to the next one, and just try to get some practice. So turn in work due on Tuesday. So you've got, do some naming practice of your choice. And then in this magenta packet, you've got a little bit of balancing to check. And you've also got a page or 10 problems to try to balance. So if you find that you've spent a lot of time here, stop and just put a note on your sheet saying I spent all the time I could spend and move on. This is really the last thing that I really needed you guys to see and practice before next year so that you know and knew what's going on. So in light of that, I know your curation is supposed to be due on the 19th. If you need to get it done by the end of the week, that's fine. As long as it's submitted by the end of the term, that's fine with me. And it will not be counted as late. So ladies, that's all I have for today. I looked at the questions. I had a few things in there. There's nothing, no questions really specific for today. So ladies, let me know if you have any questions and I will talk to you next week. And feel free to show up for any of my Zoom meetings, but they're optional. They're just if you have questions. Take care, ladies. Bye.